We built low Earth orbit to be a highway, then turned it into a minefield. Here's the contradiction. To fix the mess, we point even more energy at it, from the ground. A laser strong enough to nudge metal, but safe enough not to shred it. Because when debris collides, it multiplies. 2009 taught us that with Iridium and Cosmos, but the obvious fix hides a failure point. Push wrong, and you shift tomorrow's crash into someone else's orbit lane. In the next minutes, we map the physics, the safety systems, the failure modes, and who controls the off switch. And we'll test one claim. Ground lasers can make or break the future of low Earth orbit. Low Earth orbit is crowded. Thousands of active satellites, tens of thousands of tracked fragments, and far more untracked. At these speeds, a bolt hits like a grenade. One breakup can seed a chain reaction. In 2007, a single anti-satellite test littered orbits with thousands of fragments, many still up there. Operators today dodge constantly. Avoidance burns consume fuel and attention. Space tugs can remove big objects, but they're costly and slow. Ground assets promise speed and scale, if they're safe. The catch: weather, timing, and geometry decide your window. Miss it, and debris keeps crossing paths. Even paint chips leave scars. Crews have sheltered more than once. The risk is persistent and compounding, so the pitch is simple. Nudge debris from the ground. No launches. Fast response. But which push is safe? A soft shove or a risky burn? That choice decides everything. Step 1. Find it. Radar and telescopes refine the track, then predict the pass within seconds. The atmosphere blurs beams. Adaptive optics pre-distort the wave so space straightens it. At orbit, the spot is meters wide. Power density drops fast, so efficiency matters. Photon pressure is gentle. Light carries momentum. Over minutes, it nudges orbits by millimeters per second. Ablation is forceful. Heat boils microplumes off the surface. More push and more risk. A safe system stays below melt thresholds or uses controlled pulses with wide margins. Hardware is boring on purpose. Interlocks, shutters, aircraft detection, satellite no-fire lists. During a pass, guidance updates 10 times a second. Miss by milliradians, and you waste power. Small nudges add up. A week of passes can lower perigee enough for drag to finish the job. No one gets blinded. Keep out cones, NOTAMs, and shutters close the instant anything crosses the path. And no, we don't aim at working satellites. Catalog whitelists and transponder beacons lock them out. If it works at scale, ground lasers are cheap per target. The bill is electricity and strict discipline. Quick check. If this breakdown helps, tap like, leave your take on safe laser thresholds, and subscribe for more IfVerse engineering dives. Weather is the first bottleneck. Clouds cancel pushes. Miss enough windows and nudges never accumulate. Power is the next. High energy for minutes creates heat that must be removed, quietly and reliably. Airspace safety steals seconds from each pass. Shutters close the instant an aircraft is near. Targets differ. Dark, rough surfaces absorb more heat. Bright coatings reflect and reduce push. Spin matters. A tumbling fragment can turn your steady push into a useless wobble. Catalog errors create hard stops. If there's doubt about identity, the system refuses to fire. Liability law is unforgiving. If a push leads to damage, who pays? The operator? The nation? The owner? Atmosphere changes minute to minute. The correction system must adapt or stand down. Backlogs build quickly. The risk isn't a dramatic failure. It's death by scheduling. The temptation is escalation. Nudge harder with heat. That's the cliff edge you avoid. But even tiny drops in altitude boost drag dramatically. That leverage is your friend. Move debris here, traffic compresses there. You reduce one risk while reshaping the next. Priority rules prevent stealing margin from active constellations. The system must respect keepouts. Weather skews capacity. Global fairness becomes governance, not just engineering. Energy cost feeds back. Cheap off-peak windows may not align with passes. Batteries smooth the mismatch. Sensor hallucinations do happen. A glint can trick monitoring. Cross-checks are mandatory. Trust comes from logs. Every pulse, every shutter close, every no-fire is recorded and auditable. A single site is fragile. A network raises odds that someone sees a clear sky when it counts. We already track from the ground with centimeter precision. The question is, can we push with the same restraint? When coordination works, the whole system benefits. But it takes discipline across borders. If a site goes rogue, network keys revoke its target list. Isolation is the last safety net. Software is signed, tamper-evident, and boring by design. Edge case. Your target shares a corridor with a tiny satellite. Timelines are tight, you're pushing gently. Telemetry says you're safe, for now. Atmosphere shifts. Your corrected beam may drift into a no-go. Interlocks close. You lose seconds you won't get back. Resume at lower power, and the push may be pointless. Abort, and you risk missing the week's only clear sky. In disciplined systems, you abort. The network tries to pick up the slack elsewhere. One bad decision can multiply fragments. We've seen how fast clouds grow after a breakup. Every abort becomes a lesson. Tune thresholds, improve forecasts, raise margins. Sometimes the bravest push is none at all. Redundancy makes restraint affordable. A mature network covers most inclinations. When one site is cloudy, another is clear. Operators buy nudges like cloud compute. With logs, anyone can read. Big hulks still need capture. Lasers specialize, small, risky, fast-moving pieces. Energy systems buffer night operations. The grid barely notices the spikes. Insurance responds. Verified corridors and logs cut risk. And premiums. Academia feeds updates. Algorithms improve quietly, pass by pass. Standards matter. Shared rules turn national assets into a planetary service. Over months, alerts thin out. Risk never hits zero, but it stops climbing. The new failure mode is complacency. Cut budgets, and the backlog returns quietly. Forecasting buys you time. Better turbulence models stretch safe windows without touching power. Know the tumble, time the push. You harvest real thrust from a chaotic spin. The system learns each fragment's skin, staying safely below the melt line. Target choice is leverage. Nudge the right fragment, and you quiet a dozen future alerts. Trust isn't PR. It's cryptographic logs, independent sensors, and scheduled drills. We've hit reflectors across oceans for decades. Precision is not the miracle. Restraint is. And the off switch? It belongs to a quorum, never a single operator. That governance is your last firewall. Enjoying the failure-first lens? Press like, drop your counter-argument in the comments, and subscribe to keep exploring the edges with IfVerse. The paradox of ground lasers is simple. The safer the push, the stronger the outcome. Restraint scales. Overreach breaks things. The difference is measured in milliradians. And judgment. If lasers make orbit safer, it won't be because they were powerful. It'll be because they were governed. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.